students. I had a couple students ask me about powers of complex numbers. They were having trouble solving a problem like the one you see here on number 1 and the problem you see here on number 2. Let me go back to number 1. You might want to ask on this problem, you're like, well, couldn't I just multiply 3 halves plus 3 square roots of 3 over 2i by itself 3 times and work it out? Sure you could. It would be a mess, but it's certainly doable. 2 problems with that. Problem number 1, the answer is, I believe, a negative 27. We'll find out at the end. You're like, wow, I have to do all that work to get a negative 27. Isn't there an easier way? And also, what about this cubed? What if it was to the 5th power? You don't want to do that, right? And so what we're going to do is, if we turn complex numbers in rectangular form, a plus bi, into polar form, sure, it takes a little bit of work, but it actually makes our problem easier. And then this problem over here, z squared equals a negative 81i, seems like it's okay. Like you could just take the square root. Your calculator will let you actually take the square root, but it will give you decimal form that really would be really hard for you to turn into exact form like Khan wants. Let's go back here. Is it possible just to throw this in the calculator? Actually, it is, but again, you might get a decimal number that Khan wouldn't recognize as being exact, but the calculator actually can be useful in this one. Of course, I'm going to show you how to do the polar form to solve these problems because it is exact and you may need it in certain cases where the calculator just can't help you. So here we go. Number 1, what you already know. And my video is going to be a little jumpy. Again, it's just me. Oh, and that marker isn't working. Okay, I'm going to set you down for a second. There we go. Sorry about that. My video is going to be a little jumpy because it's just me. Well, it's just me and Princess. Princess, can you shoot a video for me? No? Thank you, though. Okay, we're back. Here's what you already know. A plus bi is the rectangular form of a complex number. That's number 1. Number 2, you know the polar form of a complex number. You did that last week. And you know how to find r. It's the square root of a squared plus b squared. And you know how to find theta, inverse tangent of b over a. Okay. Now, here's what you were given in this section on the power of complex numbers in Khan. Okay. If you have a complex number, z to the n, right here, okay, that would equal, in polar form, r, the modulus to that power, cosine times your power times theta plus I sine your power times theta. Nice little formula. Okay. Number 2, here's what else you need to know. If a complex number to the n power is equal to r cosine theta plus I sine of theta. Okay, in other words, they're giving you this problem here. Z to some power is equal to that complex number in polar form. And by the way, it kind of needs to be in polar form to work well. Then what you would do to find z, so you're trying to solve for z, you would take the nth root of r, the modulus, and you would divide each of the angles by n. Okay, let's take a look here. So again, on number 1, could you, in this case, put this in the calculator? You could, and it would work. So why not give it a try first when you're sitting at looking at Khan on your computer, right? Sorry for how I look today, people. Lots of forehead. Here we go. Now, but of course, I'm going to do this in polar form. So let's take a look here. The first thing I'm going to do is take my a plus bi and put it in polar form and then cube it. All right, let's take a look. So let's see. Here's my A, here's my B. I'm gonna find my R. So I am doing Z equals R cosine of theta, right, plus I sine of theta. And I'm gonna fill in the R and the theta, and then I'm going to cube it. All right, so just a little bit of ugly work here for the R. For the R, I'm gonna square A and square B. There we go. So here's my A, 3/2, and when I square it, that's 9/4. Plus, I'm gonna square my B. There's my B. Notice this is 9/4 right here, times 3. So that would be 27/4. So take my word for it, 3 square roots of 3 over 2 squared is 27/4. When you add these up, you get 36/4, which is 9. And when I take the square root, I get 3. There we go. Let's erase the 3, put it right here. All right, let's go ahead and find our theta. That would be inverse tangent of B over A. So that would be 3 square roots of 3 over 2. Now, divided by A, divided by 3/2. So if it's okay with you, I'm gonna multiply by the reciprocal. So here's my B, and rather than dividing by 3/2, I multiplied by the reciprocal. Notice the 2's cancel. Notice the 3's cancel. There we go. I am now looking for inverse tangent of the square root of 3, right here. If you did that on your calculator or looked at your unit circle, you would get 60 degrees. Let's go ahead and fill that in. Okay, let's step back. My problem now is 3 times cosine of 60 plus I sine of 60 cubed. Okay, here's what I know, is that what I do is, here we go, sorry about that. I take my modulus of 3 and actually cube it. 3 cubed. Then I take each of the angles and multiply by the power. Let's go back to our formula. The modulus is actually raised to the power, and you multiply the angles by the power. Here we go. So that would be cosine of 60 times 3 is 180 plus I sine of 180 degrees. Okay, here's where we are right now. There we go. 3 cubed is 27. Cosine of 180 from your calculator or unit circle is a -1. Plus sine of 180 from your calculator or unit circle is 0. Here we go. So we just have -27. That is also the answer your calculator would give you. Okay, next, let's find Z if Z squared equals a -81i. Notice that the -81i in rectangular form is 0 minus 81, 81i. There we go. Now, what we need to use our formula, if we are trying to solve for Z to some power and we're trying to solve for Z, we need polar form. There we go. So we are going to have to switch -81i to polar form. Here we go. So Z squared equals, let's take a look here. Polar form, my R, I would square 0, square a -81, add them up and take the square root. That would get us an 81 for our R. Let's get our angle. Our angle would be inverse tangent of a -81 over 0. Notice that's undefined. Undefined. Now, where is tangent undefined? That happens at either 90 degrees or at 270, right, on your unit circle. So which one is it? Well, let's take a look. If we graphed a negative 81i, if we graph 0 minus 81i, we know what that looks like. Whoopsie daisy, I just got in my own way. There we go. We know what that looks like. On our complex plane, here's A and here's B, and 0 minus 81i would be 0 comma negative 81. That would be 0 comma negative 81. That would be down here. I would be at 270 degrees. That must be my angle. I am obviously not up at 90 degrees. So cosine of 270 plus I sine of 270. There we go. Here's my new problem. When z squared is equal to 81 times cosine of 270 plus I sine of 270, what is z? Okay, remember, here's our exponent. Let's use it in the formula. Here's our formula. We're going to take the nth root of r and we're going to divide each angle by n. Here we go. Let's do that. All right, our root, let's see, we're using a square. We're squaring. So we're going to take the square root of 81 according to our formula. And we are going to divide each of our angles by 2. By that exponent. That's what we have right now. There we go. Okay. We now have z equals the square root of 81, which is 9. That's easy. And 270 divided by 2 is 135. Cosine of 135 degrees plus I sine of 135 degrees. Okay, so where do I get cosine of 135 and sine from 135? Well, you could throw it in your calculator, but it's going to give you a decimal, and Khan wants it exact, so that's what your unit circle is for. That's why I had you take the notes. Let's take a look. So, on your unit circle, cosine of 135 is a negative square root of 2 over 2, plus sine of 135 is a square root of 2 over 2. Don't forget your I. There we go. And let's distribute the 9. Z equals a negative 9 square roots of 2 over 2 plus 9 square root of 2 over 2i. Crazy as it seems, here is your answer. So I find this interesting. Take a look up here. Z squared equals a negative 81i, and they wanted to know z. Looks super easy, doesn't it? But here is actually your answer. Class, if on your calculator, I just stepped on the cat. I'm sorry, kidders. If you square this expression on your calculator, believe it or not, with how ugly it looks, you will get a negative 81i. Strangely enough, back here at this problem, it looks super complicated, and the answer was a negative 27. I hope that this has helped you, and have a great day.